What number am I holding up? 3, right? Obviously. Now, what if I told you that the symbol we use for 3, the way we write it, the way we count it, the entire system behind it, traveled across 3 civilizations over 1,000 years through a city that no longer exists before it landed in your head as something obvious? We call these Arabic numerals. Every country on earth calls them Arabic numerals. Florence actually banned them in 1299, declaring them illegal, and still called them Arabic. But Arab scholars had a different name for them. They called them Hindu numerals because they got them from India. And India built them on a foundation that took humanity thousands of years to figure out. An idea that the Romans didn't have, that the Greeks didn't have, that the Egyptians didn't have. The number 0, not as a cap, not as a placeholder, but as an actual number, a number that means something. The civilization that figured that out changed mathematics forever. We just never said their name. Welcome to the Airlearn Language Show. Every time I dig into one of these stories where a word came from, how an idea traveled, why we call something what we call it, I end up in the same place. Humbled, because the history underneath things we take for granted is almost always richer, stranger, and more contested than the label we gave it. Arabic numerals is one of the best examples I've ever found. We use this system billions of times a day. Every phone, every price tag, every timestamp, and the name we gave it is wrong. Not slightly wrong, fundamentally wrong. And the reason it's wrong tells you something important about how knowledge travels, who gets remembered, who gets forgotten, and why. That question, whose ideas we're actually standing on, is exactly what makes learning a language so disorienting in the best way. When you learn a language, you start seeing the fingerprints of those civilizations everywhere, in the words you use, in the numbers you see on your screen. Airlearn is built around that moment of recognition. Links in the description. But first, Rome. Because to understand why the Indian number system changed everything, you need to understand what the world was working with before it arrived. It's 480. You're a Roman merchant. Your supplier charges 49 coins per cart. You're ordering 39 carts. You need to know if you have enough money. In our system, 10 seconds. In Roman numerals, you're multiplying this by this. Try it. Oh, wait. You can't. Not quickly. Not without memorized tables that took years to master. And this was the daily reality of merchants, architects, and engineers across the most powerful empire in the Western world for 1,000 years. Problem is positional value. In our system, the 3 in 300 means 300. The 3 in 30 means 30. The position carries information. Roman numerals don't do that. This is always 1. This is always 10. 300 is just this. 3 symbols you count rather than read. Multiply or divide with that system and it collapses almost immediately. This wasn't a minor inconvenience. It was a ceiling on human mathematical achievement, and it stayed in place across the Western world for centuries. The solution was already waiting in India. The solution that came from a tradition of mathematical thought in ancient India that built over centuries 2 ideas that had never existed together before. The first, positional notation. The value of a symbol depends on where it sits. That's the system you use today. The second, 0. And here we need to slow down because 0 is not obvious. 0 is not a quantity. It's the absence of a quantity treated as something. A number you can add, subtract, multiply, and place in a position to change the value of everything around it. That is a psychological leap, not just a mathematical one. It requires you to decide that nothing is a thing. Most ancient civilizations never made that leap. Not the Romans, not the Greeks, not the Egyptians. These were not simple people. They were building aqueducts, mapping stars, theorizing about reality. But 0 as a mathematical object eluded them. An Indian mathematician named Brahmagupta, writing in 628 AD, was the first person in recorded history to formally define zero as a number and write the rules for calculating with it. Combined with positional notion, this gave India a number system that could do something no other system could. It could calculate, not just count. Calculate quickly with numbers of any size using just 10 symbols. Those 10 symbols are on your screen right now. And it goes further. Zero makes negative numbers possible. If zero exists, you can go below it. Zero makes the decimal system work, and zero makes binary possible. The entire architecture of computing runs on ones and zeros. No zero, no binary. No binary, no computers. No computers, no internet. The Indian mathematicians who defined zero weren't just solving a merchant's problem. They were writing the first line of code in human history. And we named the system after someone else. Move west, a century forward, Baghdad, 9th century AD. The intellectual capital of the world. The Abbasid Caliphate paid scholars to translate every important text into Arabic: Greek philosophy, Persian astronomy, Indian mathematics. This project had a name: Bayit al-Hikmah, the House of Wisdom. It was here that a mathematician named Muhammad ibn Musa al-Khwarizmi encountered the Indian number system. Al-Khwarizmi, remember that name. You use it every day without knowing it. He wrote a book introducing the Indian numerals to the Arabic-speaking world. He was clear about the origins. He called them Hindu numerals. No ambiguity. He knew where they came from. But he didn't stop at transmission. He built algebra on top of them. His second book, Algebra, completion, balancing. When European scholars translated it into Latin, they kept that word. Algebra became algebra. And al-Khwarizmi's own name, Latinized algorithmy, slowly came to mean the systematic method he described. Algorithmy, algorithm. The man whose name became algorithm and whose book title became algebra was the bridge between Indian mathematics and the Western world. And he was explicit. The numbers were not his. They were Indian. So why don't we call them Indian numerals? The answer is transmission. When European scholars encountered this system in the 12th century in Arabic manuscripts through Arab trade routes, they named it after the people who gave it to them. Arabic numerals. Not out of malice, simply because that is how naming works. You name a thing after the last pair of hands it passed through before it reached you. India had receded into the background. The label stuck across centuries, across continents, into every school on earth. And then Florence made it worse. In 1299, the Arte de Cambio, the Guild of Money Changers, one of the most powerful financial institutions in medieval Europe, banned Arabic numerals. Officially, the reason was fraud. A 0 could be altered into a 6 with one pen stroke. A 1 could become 7. Roman numerals were harder to forge. There was truth to that. But there was something else happening. These symbols were foreign. They came from the Islamic world. And the people who understood them had a calculation advantage over everyone else. Established powers have always been suspicious of systems that redistribute advantage. The ban didn't work. Better technology always wins. Within a century, Arabic numerals were standard across Italian commerce. Within 2 centuries, across Europe. Copernicus calculated planetary orbits with them. Galileo used them. Newton used them. The entire scientific revolution was built on a number system Florence once declared illegal. A number system Arab scholars called Hindu that was invented in India to solve a problem Rome never cracked. So who deserves the credit? India for the original invention. Positional notation, the decimal system, 0 as a mathematical object. The floor underneath modern mathematics was laid in Sanskrit by Indian scholars before the system ever reached the Arab world. Arab scholars for recognizing its value when the Western world wasn't ready to, for preserving it, improving it, building algebra on top of it, and transmitting it across a world still multiplying in Roman numerals. Without Baghdad, Indian mathematics might have stayed in India for centuries longer. Transmission is its own form of contribution. European mathematicians, for what they built on top. Calculus, statistics, the formalization of algebra, 10 symbols turned into the language of modern science. Nobody did this alone. It was a relay race across thousands of years and 3 civilizations. India ran the first and the longest leg. Baghdad ran the second. Europe ran the third. And got to name the race. That's how most of human knowledge actually moves. Built by Benny, named by whoever happened to be holding it when the historians were watching. But knowing the real story changes something. The next time you check a timestamp, type a phone number, glance at a price, those symbols have history. They came from a civilization that asked one of the strangest questions a human mind can ask. What is nothing? And how do you count it? They figured it out. And the whole world followed. We call them Arabic numerals. The Arabs called them Hindu. The Indians just called them numbers because to them it was obvious. The idea that changed mathematics forever didn't feel revolutionary to the people who had it. It felt like common sense. It took the rest of the world 1,000 years to catch up. Al-Khwarizmi didn't just receive the Indian system and pass it on. He learned it deeply enough to build something new on top of it. That's what happens when you actually go inside a knowledge system rather than just looking at it from the outside. That's the whole argument for learning a language. When you learn Arabic, you're walking into the civilization that preserved Greek philosophy, invented algebra, and transmitted the number system that runs the modern world. When you learn Hindi, you're walking into a civilization that conceived of zero. The history in this video isn't background. It's inside the language, waiting to be found. That's what Airlearn is built around, putting you inside the living world of a language, not just its grammar. Links in the description. See you in the next one.